Hey guys, welcome again to the Maths Club. If you are just joining us, you're welcome. Feel free to subscribe to our channel. Today we're going to be talking about matrix, brand new topic, and it will be more of an introduction to matrix, steps of matrix, and things like that will not require serious calculation. It's very important that we understand the what before we go to the how. Let's get started. So a matrix is a rectangular array of numbers or expressions, and you will see that this guy is a description of what we are talking about. So we have this matrix, capital letter A, and then inside it we have numbers 1, 2, 3, 4. It says that matrices are often denoted by uppercase letters. If you say this A, it's not a small letter A, it's a capital letter A. So when you want to define like a matrix, A is equal to something, don't use small letter, use the capital letter. And then it is defined by rows and column. So where is the row, where is the column? If you look at this guy, if this is our matrix A, which is 1, 2, 3, 4, from left to right, so in this direction here is the row. So this row 1, this row 2. From up to down is the column. So you just like in your house, you know what you call pillars. Just look at the pillars. Pillars are always straight. I've never seen a pillar that is horizontal before. I'll be interested in seeing that. So we have these pillars or columns from up to down. So this is column 1 and this column 2, and this row 1 and this row 2. So there are 2 rows and 2 columns in this particular matrix. How do we denote matrices? So elements within matrices are represented by their position. An example is Aij, refers to the elements in the ith row and the jth column. I mean, some of these things are really theory, but when we see examples we would understand better. Let's look at this. You agree that this is column 1, column 2, column 3, row 1, row 2. So this first guy here is in row 1, right, and column 1. So A11. This next guy here is in row 1 and column 2. This is A12. You can see that the row is always coming before the column. This guy here is in row 1 and column 3, A13. Same thing too for this guy. This guy here is in row 2 and column 2. That's why we call it A22. If you notice that the individual ones inside are really small letters, but the name of the matrix is capital letter. In the matrix above, there are 2 rows. You agree with me? There are 2 rows and then there are 3 columns. We can say that the order is 2 by 3. This is very important. So some questions that used to come out is, what is the order of this matrix? It's just saying how many rows by how many columns. So this is like 2 rows by 3 columns. So this is a 2 by 3 matrix. So if this is a 2 by 3 matrix, the matrix that we did before that had 1, 2, 3, 4, what do you think is the order? Great, 2 by 2, because there were 2 rows and 2 columns. So under the types of matrix, we have different types of matrix, but the first type is the row matrix. A row matrix is a matrix just a single row and multiple columns. Let's look at an example. So you can see this is just 1 row and how many columns? 3 columns. So what do you think the order of this matrix would be? Great, 1 by 3, because there is 1 row and 3 columns. Second type is a column matrix. Column matrix just has a single column and multiple rows. So an example is like this. We have a single column, but how many rows? 3. So what do you think the order of this matrix would be? Great, 3 by 1. We have a zero matrix, or what we call a null matrix. A zero matrix is a matrix where all the elements are 0. So you see this example, every element is 0, 0, 0. So we call this is a 2 by 2 matrix and is also a zero matrix. The next type is a square matrix. A square matrix is a matrix that has equal number of rows and columns. Remember the first time that we had a 2 by 2 matrix. Second time we had I think it was a 2 by 3 matrix or 3 by 2 matrix, something like that. But when they have equal numbers of rows and columns, we call it a square matrix. So an example is this guy. So it has 2 rows and 2 columns. A diagonal matrix. What do you say diagonal? You know, a diagonal is like, so if I look at my screen, so this is like a diagonal, right? From one corner to another corner. So this is a diagonal. This is another diagonal. Yeah. But this guy is mainly the main diagonal. Where's the main diagonal or the leading diagonal? We call this, look at my mouse, we call this guy the leading diagonal. A diagonal matrix is a square matrix where all elements outside the main diagonal are 0. So you can see I thought that this is the main diagonal. This guy here is the main diagonal, and it says it's a square matrix, meaning that it could be a 3x3 matrix, it could be a 4x4 matrix. But that said, all elements outside the main diagonal are 0. So let's say an example. You can see this guy here. So this is the main diagonal. This guy here, this 1 to 4, but every other thing inside it is 0 and 0. So whenever you have something like this, you know you're dealing with a diagonal matrix. It means that elements outside of that main diagonal, they are all 0. The sixth type of matrix we have is the identity matrix. Identity. It says identity matrix is a special case of a diagonal matrix. So for it to be a diagonal matrix, first it needs to be a square matrix, right? Because a diagonal matrix is a square matrix. The next, this identity matrix is a special case of a diagonal matrix where all elements outside of the main diagonal are 0 and all elements on the main diagonal are 1. So if you see this example here, first off is a square matrix because you can see this 3x3, and then is a diagonal matrix because outside of the main diagonal every other guy is 0 0 0 0 0 0. You know, in the previous one we had like I think it was 1 4 or something, but in this case whenever you're having only ones on your main diagonal, then what you're dealing with is an identity matrix. The last type of matrix that we have is the transpose of a matrix. So what is the transpose? That trans means that it's changing form. So you can see this trans is changing position. Trans, change, pose, position. So the transpose of a matrix switches its rows with its column. So if you have this guy, you can see this row 1, this row 2, this row 3, this column 1, column 2, column 3. If you look at row 1 will become column 1 because there is a change in the position. So if you look at this guy here, if you look at our column 1 is our row 1, which is 1 2 3. So just said 1 2 3, which is row 1, will become column 1 1 2 3. Row 2, which is 4 5 6, will become column 2, which is what 4 5 6. Row 3, which is 7 8 9, will become column 3, which is 7 8 9. So this is basically it about matrix. I think the thing that they will just ask you for here is which of the following is an identity matrix. I mean, if matrix A is this, what's the transpose of the matrix? Things like that. But it's always very good to understand what you're doing. So let's look at the real world example. We've talked about matrix and everything, but where really does it apply in the real world? So imagine English Premier League, and then they want to now find, okay, Man U and Chelsea, they'll be facing themselves over a period of time, over 3 or 4 games. How did two of them, what was the score difference? How did they perform in terms of scores? So you can see this guy. So we have a matrix, which is scores matrix, which is team A. Team A is Chelsea and team B is Man U. So of course they don't do 85 and 80 and all of that. So let's see, maybe two Scrabble players. So team A and team B, how have they fared over 3 games? So you can see this team A, this team B, this game 1, game 2, game 3. So team A in the first game had 85 points. Team B in the first game had 80 points. So of course team A won this. And team A in the game 2 had 92 points and team B had 88 points. So team A won this. And in game 3, I think this was a resounding flogging. Team A had 78 points and team B had 95 points. So you can see that team B did a revenge for all the times that they had lost. Just by looking at this matrix, we're able to easily see what belongs to what. So in the real world, it is used for easy representation of values, especially when it comes to computing. In the real world, we use it to represent values in a visually appealing manner. This is information. We're spreading information. Before, where I just add 1 2 3 4, in the previous ones were just numbers, but like this is a complete information. So this matrix allows us to easily compare team performances, find the total score for each game, and perform various analyses on the tournament's results. So that is it about matrix, introduction to matrix, what is matrix, and we've seen a real world example. You can go on the internet and find more examples on all of what understands. In the next video, we're going to be taking it a notch higher, where we'll be doing more of the calculation and all of that. I'll see you guys in the next video.